Hello, sir. Uh, we are presenting the project presentation for the Edge and Fog Computing project, and I am accompanied with my friend Rajesh Chaudhary in this project, and we are going to present a project on alert system for monitoring air pollution, and we have taken the reference for the Jodhpur system, where the air pollution parameters are being calculated on real-time basis, but due to shortage of sometimes of resources, we have collected the data in a in an Excel sheet according to the parameters, and as per the reference points, we will be calculating all the parameters of the pollution where the danger zone or the polluted area will be highlighted, and the alert can be sent to the users on their via email address. Now, sir, as per the project content, which is on the alert system for monitoring air pollution, this will be very helpful for those people who want to travel to a specific certain place. Like if we give an example of Jodhpur, if they are going to if they're willing to travel to the city area in a peak hours, they will get to know the air pollution parameters in that area, and accordingly, those people who are asthmatic or going through medical ailments, they can skip that time traveling, or accordingly, they can choose the other areas for the shopping or any other purpose. So in those cases also it is very helpful, and it will be helpful for the environment friendly people to take certain protective actions by the government in those areas where the pollution is very high. If we collect all the parameters on a real-time basis or monthly basis or weekly basis, accordingly we can keep a track and we can grab the pollution control in the in the city accordingly. So what we are going through this in this project is that the overview of the project, that we are implementing the air pollution system using machine learning prediction using the fog and computing techniques. In this technique, we are using fog technique where it is efficiently used to feature. We are using the fog layer and edge layer architecture, in that the sensors positions are nearly on the edge, and the prediction logic is done by the machine learning algorithm. In this, we are using Python language for the implementation and all doing all the mechanical and mathematical work of the calculations done. Accordingly, the AQI quality of the air system logic at cloud layer, it is we have made one cloud server is also there, which will be handling all the logics where all the AQI quality parameters can be calculated. Now, if we go to the proposed design deeply, we have on top of the layer, we have the cloud layer where AQI parameters will be calculated. We have fog nodes where all the we have collected the input data we have given through CSV node, where we have given 15 sessions for 6 parameters of air pollution. Accordingly, we can manage in the real time also. Either we can calculate it in every 15 minutes, or we can calculate in hourly basis or accordingly. But due to shortage of resources, we have given an input to the data in an Excel sheet. All these input data will be done in the fog nodes. Accordingly, the collected data is received at the fog nodes, and the machine learning technique is used in the layer to train and predict the AQI parameters of the data received from the sensors. In case we implement sensors, then the input data can be replaced from sensors, whatever data the sensors are providing to the system. Here we are giving the input data from the Excel sheet. Now the cloud layer is responsible for the receive all it will receive all the AQI data from the fog layer, and the AQI parameter monitoring logic is implemented in this layer to interpret the severity of the logic, as well as the end user notification logic is also implemented in the cloud layer only, where via email address we can send n number of emails uh, according to the sessions, according to the instances, to n number of users who are willing to use this type of technique. In case of implementation, what we have implemented in this our short project is that instead of sensors, we are using modeled sensors, data received in the form of dataset entries, and we have prepared two data set entries, one for the training and one for the testing purpose. Accordingly, which will migrate all the output, and if the sensors will be available, it can be replaced through them. Now the fog layer is used where the prepared all the logics will be prepared at the fog layer. For the machine learning model where we have trained a model and used the predicted values of AQI because of shortage of sensors, the cloud layer will be predicting the AQI predicted parameter values stored, and based on the interpretation and alert logic which is implemented in the cloud layer itself, the AQS severity is notified to the end user via email address. Now, sir, accordingly, like we have only used the email address here, accordingly we can also send it by through SMS. In case of SMS, there will be a logic required with the telecom implementation where the SMSC and all the parameters will be involved. Because of shortage of resources, we are going to the email address. Now, for the code implementation of the Python, what logic we have implemented in Python, what calculations are done in the cloud layer, my friend Rajesh will be taking care ahead from there.
Thank you. Yes, sir. Actually, for the implementation part, as actually the data should be received from the sensors, but in order to mitigate because of the resource crunches, whatever the data the sensors will fed from the edge node towards the fog layer, we have actually make a Excel CSV data for the same. Like rather than keeping the real time data of 15 minutes, if some sensor is reading taking the reading for every 15 minutes, we have clubbed that data as a whole, and we are trying to train our model in the fog layer to get it trained and predict the values in the fog layer. So the furthermore the implementation for this will be like, we have written the code in the Python. For example, in the fog layer, we can see that there is a data training set, which is the air population data, which is actually the sensor data, which the sensor will be collecting at each 15 minutes or interval. We have make the six features, and the seventh is the alert one. So based on this data, we have divided our data. 80% data is for the training, and 20% is for the testing of it. And there is another real-time data which we are getting it in the another CSV, which is actually calculating the real-time scenario to predict whether it is a severity or not. So the code will generate work at the fog layer is like, this is the actual machine learning which we have implemented in the fog layer in order to predict the values, and it will be fed it to the cloud. Let's run. Let's show you the running. And in the cloud layer, we are actually implementing the logic to store the data in the cloud layer, as well as to send the alerts to the users. And based on the probabilistic values, we will send whether the quality is good or not. We have implemented this logic over in the cloud layer node. Let me run this one also. Now I am calling this function in order to actually, the main cloud layer is the main one, which is actually now for running the whole of logic. And now it is starting collecting the data from the fog layer based on the training, and it will start predicting the data. The layer is started it processing. The processing is started. Now it is collecting the data from the fog layer, and the sample data is around 1500 samples there. So it is taking some processing in order to complete it and to start predicting the value. The resources is having crunch in my laptop, so it is taking some time. So bear with us. Yes. Now it is start. Now the logic for the sending of the email is started from over here. I am providing the password for my uh, uh, processing of the data. I have provided it. Now it is started to send the email, over our IIT mail IDs because we are actually the subscriber of the same, and we can see over here that in the real time we are getting the alerts that the air quality is poor as soon as now we have got because we have providing the Excel CSV data to the rather than a real time scenario where the input value will be having a time interval of 15 minutes or the pre-defined value rather than it is Excel, so it is sending me the frequent alerts. What is the air quality value, whether it's poor or not, it is sending the required detail. So this is how we have implemented the layer at the fog and the edge and the cloud. And furthermore, I would like to call Gajendra to explain this one further. Yeah, Gajendra.
In this PPT, sir, what we are implemented an example, what we can set that at if we are at Jodhpur and these six parameters are there for the pollution control, and accordingly, these are the data collected from the internet where the Jodhpur is having such parameters in the peak hours of the traffic, and accordingly, the PM value of the Jodhpur is the graphical representation monthly wise. This is the yearly data which has been collected, and accordingly we can implement and we can collect the data as per our project based, and if we go for at a large scale, accordingly we can uh, calculate yearly wise, monthly wise, weekly wise, and area wise, and accordingly we can generate the data and give it to the government agencies where they can implement some type of techniques to reduce the pollution according to like vertical planting or any carbon insulators which can absorb the pollution, or likewise, or accordingly the traffic police can use to shift the traffic from that area in order to reduce the pollution levels. So this is just an example where how an EAD data can be represented graphically. So this is our small project, but due to some limitations of resources like sensors and all, we are using the input data from two CSVs like Rajesh told informed, and accordingly this project, if we take it at a large scale, this can be very much effective for the smart cities or for the urban cities where the pollution is a major problem right now. Rajesh.
Yeah, thank you. So, due to the global warming and the green initiatives, which currently ISO is also helping us out, so monitoring is also as prominent part as the corrective measurements. Because if we are not able to measure whether something is wrong happening, we can't take a corrective actions. So, our proposed solution actually helps in monitoring of the environment, as well as it actually provides a mode to alert the users about the same to keep as good healthy state of one's health. So this is what we have successfully achieved in this project to how to implement using fog and edge computing. So thank you
Thank
for
you, sir.
it.